Okay, so today we are going to talk about merge sort, and I'm going to first explain manually how merge sort works, and then we are going to implement it in C++. So merge sort is a sorting algorithm with an complexity of nLogn involving a recursion, a recursive algorithm. Right. So let's explain it. So this is the array we have. So in merge sort, what we do is first divide this array into two halves, left side and right side, and then continue to subdivide in that way. And after that, we sort the divided arrays and merge them together in a sorted manner. So at the end we will have the sorted array. So here we have 1 2 3 4 5 6 7 elements. If I divide 7 by 2, I will have 3. So this part would be the first half, which is 5 1 8, and the second part 3 6 2 7. So this is the left half and this is the right half. Right, let me mark it like this. Okay, then let's consider this part. So here we have 3 elements. So if I divide 3 by 2, the integer part of that would be 1. So I'll have 1 as the left half and 5 as the left half and 1 8 as the right half. And similarly here 3 and 6 would be the left half, 2 and 7 would be the right half. So this part cannot be further subdivided, but these 3 can. So these 3 would be, you get it, 1 and 8. So single cell arrays, 3 and 6. And 2 and 7. Okay, now we start merging. So first we can merge these elements. So let me together. Wait, let's use an arrow. This and drawing arrows is tedious, so I'll just explain it. So 1 and 8, when we consider 1 and 8, 1 is the smaller element and 8 is the larger element. So the merge sorted part again becomes this 1 and 8, and this one nothing to be sorted there because there is only one element, so this becomes 5. Okay, and then we have to consider this part and this part. So when we merge it, first we have the smallest element 1, which comes here, and then 5, then 8. So when we merge them in a sorted manner, right? So now this part is already merged, and if we consider these two, when we merge, well, this is already sorted, but when we merge, we get it like this: 3 and 6 sorted, and these two again sorted, 2 and 7 when we merge. So now these two will be merged. When we merge these two, 2 is the smallest, then 3, then 6, then 7. Now this array independently is also merged, also sorted. So now we have to combine these two arrays. Smallest is 1, then 2, then 3, then 5, then 6, then 7, then 8. Right, now this is the merged array. So let me draw the lines now. Right, now this is the splitting happen. This is the way the splitting to left and right parts happened. This. Okay, then margin part is like this. So this is same, nothing changed. These two merge together, these two merge together, these two merge together. Okay, so here finally we have the sorted array. Right, now this is how basically merge sort works. So now let's see how to implement it in C++. So here, now this is the same project we used for bubble sort yesterday. Let me remove that. So numbers are like this, and size of the array we can calculate this way. Right, now here I'll add a function void merge, sorry, not void. Yeah, void is fine, no need to return anything. Void merge sort. So here we need to give a sub array because we divide the arrays. So to allow that, first I'll add a parameter arr array, and then int start, int end. Okay, so this will define the starting point of the sub array and the ending point of the sub array. Right, now here I can call merge sort with numbers, and initially starting point would be 0 and end point would be size -1, because if there are 10 elements, the last index would be 9. So that's why size -1, because index starting from 0. Okay, so first we need to divide this. For that we need to find the middle point. So I'll define int mid as the start and end divided by 2. So the middle point we can get it like this. And then size of the left array and the size of the right array. We need that when we define the temporary left array and the right array that we are using for merging. So int L equals m minus start -1. Sorry, not m, mid. Sorry, not 1, not -1, +1. Because if I consider this example, here we have 7 elements starting from 0, ending from 1, 2, 3, 4, 5, 6, 7. Yeah, 7. But the final index is 6. 0 plus 6 divided by 2 means 3. And here 3 is the middle point. So the size of the first half would be 1, 2, 3, 4. 4 elements. So mid minus start +1. And the size of the right half of the array, int r equals end minus mid. So end is already 6, mid is third index, mid index is 3, then 6 minus 3 is 3, so we have 3 elements here. Okay, so that's the size of the right half. Now according to the algorithm, what we need to do is merge the left half, split this into 2 halves and sort them independently. So if start is less than mid, we check for this condition because if we get a single element array, these two would be similar. So in that case, we don't really need to sort anything. So if that's the case, we can avoid calling the recursion. Otherwise, we can again call merge sort arr, and starting point is the start index, which is this one, and the endpoint is actually midpoint. So up to the midpoint from a start we get as the left half, we consider as the left half, and then we call merge sort on it, so that half will be independently sorted. And for the right half, if mid plus 1 is less than end, so if the right half has more than one element, this condition must be satisfied. Otherwise, that will also be a single element array, which we don't need to sort. If it is true, we can merge sort arr. Here starting point is mid plus 1, as I explained before, and end. So we are calling the same function, merge sort function, from here as well. So that's why we call it a recursion, because we are recursively calling the same function within that function. Okay, and after we sort these two parts, what we have to do is merging, and after this point we do merge left and right parts. Right, so to do that we need to have two temporary arrays that represent the left part and the right part, right half of the array. So here int pointer left equals new int. This is where I need L, the size of left half. Int pointer right equals new int r. Right, and yeah, then we need to copy the elements of the left half and the right half of this arr array into these new arrays, newly defined arrays. So for int I less than L, which is the size of left half, left I equals arr starting point plus I, because we only need to consider whatever the given part of the array using these parameters, and then we have to subdivide that given part. That's why from whatever the starting point to ith element to up to this L length, we have to consider as the left half. Similarly for for int I is less than r, which is the size of the right array, right half right I is equals arr mid plus 1 plus I. Mid plus 1 is the first element of the second half of the array, right half of the array. Right, now we have the left half and the right half. Now all we have to do is merging them in the sorted order. So here I'll define 3 more variables. Integer il equals 0, which stands for left array index, and integer ir stands for similarly right array index, the index that we consider at the time, and int I merged equals 0. That is, sorry, this shouldn't be equal 0, this should be the start value. So index of merged array. Now how do we combine these two arrays or concatenate them together in a sorted manner? So for that, let's run a while loop. il is less than l. So as long as il, index of left array, is less than the size of the left array, we can run this. If ir is also less than r, so this condition also must be satisfied, otherwise we will run into index out of bound exceptions. If so, here we are going to compare the values of values in the index of il and ir, and then we select the lowest value and put it first into the merged location so that we can sort it. So here left value means il if that is smaller than right ir, then that should be first added. So arr I merged equals left il. This should be the right array element should be added. Right ir is merged. So if we do this, that means we have to increment the il, because we have already added one element of the left array, so index must be incremented. Similarly, if we add a right element, right index should be incremented, and this is else. And if this condition is false, that means we have already added all the elements in the right array into the merged array. So in that case, we are left only with the elements in the left array. So that means we can just add whatever the remaining elements in the left array into the merged array. So that means the original array. And in any case, we are adding elements to the merged array. So I merged should be incremented anyway in this loop. Now also there could be remaining, this becomes true means all the elements in the left array is already added, but still there could be remaining elements in the right array. So if IR is less than R, as long as that condition is true, we have to add the elements in the right side into the merged array. So I merged should be incremented here as well. Right, now all we have to do is testing. So let's use the print array function that we have already written, numbers and the size. So after calling merge sort, in the first line it should be numbers should be sorted because the numbers array is passed as a reference, and then print it. So let's see. Okay, here we have 4, 5, 5, 6, 7, 8, 11, 12, 23, 45, 45, 65, 18, 7, and those are the elements we have. Here this is the original array, this is the sorted array, and it works. Okay, alright, so if I want to show the steps here, let print array. Here let me print left, size is L. Here I'll add a C out, left, so we can sort of see the what's going on in the algorithm. Let me print left and right. Now here are the steps. Initially we have 5 in the left and 23 in the right. Let's okay, so these are the sub arrays that we get, and you can see step by step they are getting sorted. Alright, and here is the final result. Okay, I hope that's clear. Oh, in case you didn't clearly see, I forgot to zoom in. So here is the complete algorithm. Okay, and thanks for watching. So as always, project files will be available in the Patreon page for this project and also all the other projects that I do as well. And see you in another episode. Goodbye.